This is a video presentation for parents and students designed to help you decide which IB Diploma Mathematics course to take. There's quite a lot to consider, so let's run through the key choices to start with. So you now have a choice between two different mathematics courses. One is called Applications and Interpretation, and the other is called Analysis and Approaches. And you can do both of those courses at standard level or higher level. So if you like, you've got 4 options to choose from, but your choice is 2-stage. You've got to decide which of the 2 courses you want, and then you've got to decide whether you're going to do it at standard level or higher level. So let's go over some of the key differences. Both courses centre around these 5 key topics in mathematics. But the applications course has a strong focus on applications of mathematics. It's about how mathematics is used to help understand the world around us, with an increased emphasis on technology to process mathematics, where you get to focus on what the result means. The Analysis and Approaches course is something we might recognise as a more traditional mathematics course. Definitely a mix of pure and applied maths, but with a focus on pure approaches and thinking. Much more akin to Einstein's wonderful view of mathematics as a poetry of logical ideas. It would be wrong to consider the 2 courses as applied and pure, because both will have a mix of pure and applied mathematics. It's just that this course will have a much stronger emphasis on applications, where this one has a stronger emphasis on the pure maths ideas. It's not really a binary choice, just so much of a change in emphasis. Here's a Venn diagram to show a little bit of the relationship between the 2 courses. So we have got this intersection in the middle where 60 hours of the content is common to both the applications and the analysis course. So all students will do that same 60 hours. Then each of the SL components have 90 hours, and then a further 90 hours goes to the HL components in each. And here's the scale I was talking about. Between applied and pure, we just shift more towards the applied in this one and more towards the pure in that one. Clearly there is a big overlap between the ideas because it's all mathematics. As I said already, it's just a case of emphasis. So let's have a look at what is the same and what is different. Well, I think this is a really important point. It's all mathematics, right? So it's not as if we've just invented an entirely different subject for you to study. It's just a different emphasis and maybe some newer mathematical ideas to the school scene than there has been before. Both are based around these 5 main topics: number and algebra, functions, geometry and trigonometry, stats and probability, and calculus. In both courses, we're underpinned by the same key concepts, aims and objectives. And both courses have an internal assessment element which is worth 20%, and it's marked with the same criteria. And there are these 60 hours of common content that are the same for those 2 courses. So that's what's the same. Let's have a little look at what's different. Well, like we've said, in applications and interpretation, focus on applied. Analysis has an emphasis on pure. The subtopics and the details of the 5 main topics will be different to reflect that different philosophy. Regarding technology, in applications interpretation, you always have your GDC. Whereas in analysis, there is a large element that you have to do without technology. And again, that reflects the difference in philosophy. Although the internal assessment is marked with the same criteria, because some of the mathematical details are different, you might find yourself using different maths in your internal assessment. And although these 60 hours of common content are the same, it's conceivable that they'll be approached in different ways to again reflect the change in philosophy between the different courses. So first up, you might want to be thinking which of these two emphases you think is best suited to you, your preferences, and what you might like to do next. Then you've got to decide whether you're going to be doing this at standard level or high level. And for some of you that'll be easier than others, but there are a few considerations. Have you achieved well enough in your previous experiences? Can your teacher verify that? They're the right people to ask for advice. Maybe you have, and that's great. If you've got the kind of grades that your teacher in school is recommending are right for HR, then great. If you haven't, well, maybe IB is your moment, and nobody's going to turn you down the opportunity, but you've got to be sure you've got the time to commit to making up some of that gap if your previous achievements are not quite at the level they need to be for doing high level maths. Do you need high-level maths for what you want to do next? That's a really key consideration. Now, that's not to say that you shouldn't do it if you don't, because maybe you want to do it because it's your preference. But it is important to know how much you rely on that. But probably the biggest factor is about how much you really enjoy doing mathematics, because at higher level, you're going to do a lot of it. And the more you're enjoying it, the better experience that's going to be for you all around. It's probably worth noting as well that for some subjects at IB, the difference between high level and standard level is less obvious than it is in mathematics. That's the different nature of subjects. It's bound to be that way. In some cases, the difference is just more content. In maths, it's very much the case that it's more content and it's harder. So we really feel there's a big gap between SL and HL, and we think there should be. We think that's right. The SL courses provide a fantastic bit of groundwork in mathematics that will have lots of applications to different university courses and things that you want to do next. And the HL is that big step up to really push you in those directions. So what do you want to do next? This is probably going to be the biggest factor in your decision, and it's one of the hardest for us to answer. And so I'm going to point you to this bit in the middle. What I'm saying here is just a guide, and you really do need to check with your chosen universities. Maybe you don't know yet, but it costs you very little to speculate. Have a look at some university websites and some of the courses that you're thinking about doing, and look for what they're asking for. And if you can't see it, send an email to the admissions board. It doesn't take long, and there's no substitute for getting an answer direct from the school that you're looking at. There are going to be various interpretations of these courses in different universities and in different countries, and so it's really crucial that you take that step yourselves. We can give you a guide. So we think for analysis and approaches high level, engineering, computer science, maths and physics keeps a lot of your options open if that's the direction that you're heading in. But the high level applications course will definitely be good for some sciences and many engineering and computer science courses, and certainly those in the direction of data science. The philosophy of the new applications and interpretation course is certainly going to appeal to a lot of degree subjects. As far as SL is concerned, well, for the SL analysis, you're probably going to look at that for some medicine and some science courses where higher level is not necessary. And again, you might find that the SL analysis option keeps more doors open for you. But the broad range of applications in the SL applications course is certainly offering you a lot in terms of supporting many of the other degree subjects that are available, particularly those where mathematics is not a main focus. The course is going to cover lots of the ideas that you're going to see broadly across a range of other subjects of study and the world of work. But please do remember that this really is just a guide, and there's no substitute for checking your universities and your courses that you want to look at. So next consideration is what suits you best, and don't overlook this, right? You've got to think selfishly about this. What kind of mathematics do you like to do? If you like your abstract problem-solving mathematics and aren't too fussed about whether it's in a context, then the analysis might be better suited for you. But maybe you're somebody for whom mathematics has really only come to life when you've seen it in an obvious context so you can relate to its meaning straight away. That makes a huge difference. You're going to spend a lot of time studying these courses. So knowing which of those is your preference would be really helpful. Do you see mathematics in your future? Then higher level is probably going to be a good choice for you there. Or have you had a love-hate relationship with mathematics? I think we'd have to be honest and say that for those people in that little cloud there, we feel like the Applications SL course has got the most to offer, because it's a new opportunity to see mathematics in a new light. How does your maths choice suit your other subjects? There are some good combinations that go together. Lots of the statistics on the Applications course, for example, goes very well with some of the humanities or the human or soft sciences, as they're called, like psychology and so on. Whereas the analysis often fits well with something like high-level physics. These again are just examples, but we're really inviting you to consider and discuss with your families and your teachers to see which pairings go well together. And of course, we've already covered this idea. What's the one that you really need? But it's got to fit in the whole picture of what suits you best. Speaking more generally, I thought it was probably worth talking about the rationale behind these courses. The IB have a policy that they review all their curricula every 7 years, which is great, gives them an opportunity to keep up with the times. But mathematics remains mathematics. We're not making up new ideas. This is very much an evolution, not a revolution. But there is an acknowledgement that more people are using more mathematics in more ways than they ever have been before, and that technology has changed the way people use mathematics. There's much more scope for allowing technology to process the maths and allowing the user to be the person that understands the purpose of the test and interprets the result. And at the same time, it would be foolish not to recognize that there is still an essential need for that traditional mathematics element that's provided by the analysis course. Mathematics is a vast and varied subject, and school has only ever been able to scratch the surface of some of the key ideas. What's happening now is that we're seeing an option for IB students to take a slightly different direction with that mathematics and explore different areas than they've had the opportunity to do so before. But obviously still able to offer very similar ideas to the ones we already have. So really we just have a broadening of the options that are available to people now, which can only be a good thing. So this has just been a quick presentation to give you an overview of the elements you want to consider in your decision making here. Please read on the rest of the information that's on this page, and most importantly, talk to each other. Have discussions with your families, with your teachers, with your peers, and ask questions. Ask questions of all of those people, ask questions of universities, and just do your best to make the decision that suits you and your future direction from now on. Good luck, and thank you for listening.